Welcome back, fellow tech enthusiasts. Today we have an interesting problem to dive into. The issue at hand revolves around the intricacies of floating point values in Java. The problem arises when attempting to create a float value using raw int bits with a mantissa has all bits set to 1. However, upon casting this float to a double, we notice that the final bit in the mantissa changes from 1 to 0. Quite the puzzling situation, isn't it? Now, let's delve into the solution for this intriguing problem. As it turns out, the conversion from a float to double is not actually losing any information. The reason for the discrepancy lies in the nature of subnormal and normal floating point numbers. Your float value is considered subnormal, which means it has an implicit leading bit of 0 in the mantissa, rather than the 1 present in normal floating point numbers. Consequently, when casting this subnormal float to a double, the implicit leading bit changes to 1, aligning with a normal form of floating point numbers. This behavior preserves the 23 consecutive 1s in the mantissa, just with a subtle difference in representation. In conclusion, despite the initial perplexity caused by the discrepancy in the mantissa bits between float and double values, the conversion between the two is actually seamless. The understanding that subnormal floats have an implicit leading bit of 0, while normal doubles have it set to 1, clears up the confusion. And there you have it, another problem unraveled in the vast realm of Java programming. Keep exploring, stay curious, and don't forget to like, subscribe, and drop a comment below with your thoughts or any tech conundrums you'd like me to tackle next.